Okay, welcome Jacob and Ralph and Cesar and Jordan. Welcome to linear algebra, a very unique class. It's a tough class. I give you a warning. It's a tough class. Most people pass it. Welcome, Bradley. It's a tough class. It's one of these weird, we do have a pre-req of third quarter calculus, but we actually don't use any calculus, or just a bit, almost no calculus in this class. That doesn't make it easy, by the way. And let me share my screen and we'll talk about the syllabus and talk about what we're doing in the class and how it's going to work out. Okay, so again, welcome. This is linear algebra. It's the Math 203 class. And we're going to be meeting Monday, Wednesday, Friday, 1 o'clock to 2:45. And this is an Eve class, similar to what we had all year. And unfortunately, we can't get out of it. Eventually, maybe someday, but not yet. So this quarter is fully on computer. Maybe towards the end, if they let me, I'll do a review session or something, if they let me do that on campus. Because by then, if all things are good, and I think they're going to be, I'll be vaccinated. So I won't be in danger to any of you. I'm not sure about you guys, but I think they're talking about teachers being next on the list. So we'll see. And then I'm safe at least. And you're pretty safe too, because you're younger, most of you. So I think I know all but one person in the class. Aha, now people are coming in. Hi, Victor. So everyone but Jordan. And let me introduce myself. I'm going to have you introduce each other also, because again, this is a class where you need to know each other. It's important. And so I've been teaching. This is my 25th year at LTCC. And I actually have taught this class from the beginning. Okay, and I taught it before I was here too, when I was at Sonoma State, and as a part-timer. But the class I can do in my sleep basically. Doesn't mean you'll be able to do it in your sleep, but you'll be able to do it, or maybe you'll do it in your sleep because it'll be your nightmare. That could happen too. But it's a tough class, and maybe if you don't mind. Or maybe I'll do that next time. I'll do an introduction because we're being recorded. I'll do an introduction when we're not recorded so that you'll feel more comfortable. So we'll introduce yourselves. You can introduce yourselves in the chat. That's a better thing. That's not recorded. So that maybe you can mention something about yourself in the chat box so that you can talk to each other. And I want to remind you that there's a webinar. Feel free to ask questions anytime, and I'll be here to help. I have a list of some of the lecture notes, although they're older, so we've changed books since, but linear algebra is linear algebra. It doesn't really change, just the order a little bit changes. The textbook we're using is by Cutler. Okay, and as you know, well, most of you know, one person doesn't know me, but the rest of you, is that I don't make you pay for anything. So I make sure that the book is free. So there are two versions of the book. There's this one here. And this version doesn't really have the homework assignments, but it's a little easier to navigate and stuff because you can go to the chapter and then you can click on the section or whatever. Whereas the other one's a little harder to navigate, but there's a copy of the other one in a different form. And for example, we're in chapter 1 today. So we can go to Gaussian elimination and look at it. This is also easier to get a print copy. Okay, although it's hard to hit print, but there's a print copy button on this one. Okay, and then if we go back to the syllabus, there's another copy of it. And this was the original version. And this is just a big, long PDF. What I don't like about this one, it's kind of a pain, is you got to go scroll a lot until you find the table of contents. And then you can click what you want. So there's our table of contents. And we can click to chapter 1.
You said the homework's in this textbook?
Yeah, this one has the homework problems. The other one doesn't have homework problems. So sorry about that. The other one's easier to read. This one's easier for homework problems. I figure it's free. Maybe it's worth it to spend $300 to have that happen in a publisher's version, but at least when I was a student, I wouldn't think so. Because that's really the only difference between this and a publisher version, is that $300 and it's a little easier to navigate. So that's the book, and it's a standard textbook, just let you know. So then, just gonna go over quickly because most of you have had me before, so you kind of know, my style. I'll let you read through the course descriptions, student learning outcomes, 90, 80, 70, 60. There in this class, this is a little different in one way, is I don't do quizzes. One of the things that I think is really important is that I teach this in a similar way you're going to see at a university. Universities don't give daily quizzes. So I try to make it as similar as I can, although hopefully next year you'll be at the university and you'll actually go to class and you'll sit in a chair with everyone else.
But yeah, I'm kind of getting sick of sitting in this chair.
Yeah, at least my cat is next to me, but that's actually happening. That's not because of me. That's just COVID. But other than that, I try to make this just like a university class. So there is homework. That's 15% of your grade, which isn't that much. You don't do the homework though, you can do bad on everything else. So that's not going to matter. I have 2 exams. There is a presentation that you're going to be doing. And then there's a final exam. And that's the breakdown of the points.
Will we be using Proctorio on the exams this year?
That's a good question. Oh, you know what? I'm thinking, that's a good question. I decided no. So the reason why I decided no is this is a very special class. So there's a bunch of things involved in this class that aren't in other classes you've taken with me. One of them is timing. I am assuming, which might be a false assumption, but you should get your act together if it's not true, that you're going to a university next year. Is that true of all of you? Okay, you need to be done with being a community college student. You're not supposed to live in a community college. This is our last year of math. I mean, there's nothing left. So the hope is you're out of here, okay? And out of here to do better things, and that is go to a university, which means you've already applied to the university. They've already looked at your transcripts. Your grades don't matter. I don't know if you realize that. You need to pass, but if you work hard, you'll pass. So you shouldn't be as concerned about the grade as you would be. And I don't usually say this in regular classes, but in regular linear algebra classes, but because I'm not using Proctorio, I'm saying it. What matters is learning. And I will tell you, and I know this, I don't know actually why, but when I talk to students who are engineers, and a lot of you are going to be an engineer, that's kind of the typical thing, and I ask them which class is the one that they need and use the most, they say linear algebra. If you don't learn how to do this stuff, you're going to be screwed next year. Not because of a low grade. You're going to be screwed because you need to know this stuff. Whether you're a computer programmer or whether you're a mechanical engineer or whether you're an aerospace engineer, you need linear algebra. Okay, it happens everywhere in the high level stuff, which is what you're all in, or you wouldn't be in this class. So hopefully I don't need to convince you not to cheat. You cheat and you won't make, you'll fail out next year and you won't make any money when, and even if you could pass next year, you won't make it in your job. So you need this stuff, just let you know that. And I actually don't know exactly why. I'm not an engineer, but that's what the engineers all tell me. Okay. Honestly, vector calc is kind of cool and stuff, but they don't use that much in their job. But this stuff they use. Just let you know that. So take it seriously for your life. Does that make sense? Okay, which means the presentations should be easy to find because there are lots of really cool applications that involve linear algebra. And again, I can't explain that now because you haven't had linear algebra yet, but it's going to happen. So
Is
I'm
it going
not
to be
using
a similar form to our last presentation that we did for
a little bit different one. This smaller class, so it's going to be longer. That's the main thing. It's also second year instead of first year, which means you should be more advanced. Okay, you may not like what I'm about to tell you, but you are the all-stars at our college now. There are no other students that are better than you are in the high-level STEM math stuff. So means that you can do an all-star presentation. So you may not feel it, but it's true. Okay, so that's why I have high expectations, similar but longer, and I'll guide you to lots of applications. Okay, and again, it doesn't happen until March 22nd, so it's a little early right now to go into any details. You can do it with partners. Yeah. And so far, I haven't checked in 2 hours, but we had 9 students, so that means 3 groups is best. 3 threes. Okay. So the exams, again, you're going to get an exam. It's not going to be proctorio. You're going to be on your honor. It's the other reason why I'm not doing proctorio is this is a very different kind of class in that this is all about matrices. I don't know if you realize that, but this class, linear algebra, is matrix theory. And matrices are a pain in the butt to type out. It's going to be my nightmare because it's really hard to do. So the tests are going to be written. I'm going to give you, I'm going to have the test typed out as the test, which I would do in a regular class too, except I put it on a piece of paper for you. And then you're going to have a paper and you're going to do the test and you're going to take a picture of each of the pages of the test. And that's what you're going to submit is the picture. They are timed. So they're 2-hour exams and they're an hour 45 minutes for the 1 and 2. And you do that, take a picture of what you've written, and then I'll grade your test that way. Does that make sense? So this is pretty different than testing wise that you've seen before. And again, you cheat and you are screwed in your career because you need this stuff. Homework turned in. Actually, I think I copied and pasted this from last year. Not really turned in at the end of class. You submit before class. Sorry about that. So that's a typo. And it's good. And homework is not my open math. Okay. This class, as I mentioned, is a lot of writing. And my open math or any homework system doesn't do writing well. So there's proofs involved, there's matrix, step-by-step stuff. I tossed on this one for a while and realized, you know what? It's going to be like the tests. You're going to get a piece of paper. So if you haven't already done so, you need to go to the store and buy a notebook of paper. You need a lot of blank paper for this class because all of your homework is going to be on paper. So you're going to do that and you're going to submit it. Obviously, you got to submit online because we have no classroom. But you're going to submit it via Canvas using a picture. Does that make sense? There's a lot of things that haven't changed yet. Sorry, my office hours are not 8 to 10. I think that was my hope. I was like, oh, I really hope we're back. And we weren't. My office hours are my living room. I thought maybe I'd be able to be in 8 to 10 when I wrote this, and they told me no. So I'm not allowed on campus. But the times are right. So are they? Yeah, Monday. No, even these. Sorry about this. I thought I fixed that. Maybe it didn't keep. Yeah, they're Monday, Wednesday, Friday after class. And they're Tuesday, Thursday from 10 to 11. I'll fix that one after class. So Tuesday, Thursday, 11 to 12. Tuesday, Thursday, 11 to 12. Monday, Wednesday, Friday after class. And that'll be fixed by the time our class is over.
Will they be through Zoom?
Yeah. Same link. That's all I can do. If things go really well in March, maybe I'll even have a couple face-to-face stuff. But it's going to take a lot of convincing. But my hope is that I'll be vaccinated. So I won't be able to give it to you. But I don't think they'll let me. But if they let me, I'll do that. And then we can do face-to-face if you want. But I don't think they'll let me. I figure if I'm vaccinated, I'm totally safe. But we'll see. Here's the homework assignments. And each one comes from the book. One of the things that is a little weird about this book that I don't like is that they don't section it very well. There are some sections that we're going to spend days on, and there's other days we're going to have 2 sections in the same day. And that's because some of these sections go on and on and on and on and have so much material. So like today and Wednesday, so today and Wednesday, we're going to do 1.2. And then, today and Friday, we're going to do 1.2. And then Friday, Monday, and Wednesday, we're going to do 2.1. But then if you look later in the class, like on February 5th, we're doing 2 sections in one day. So don't get scared about that. That's because this book has sections that are like a few pages and that's it. And then other sections that go on for 20, 30 pages. So I've split it up. So it's kind of the right amount of material per day. Okay, it's something. And another thing I didn't like about this book, and this comes at the end, and I'll mention it. They got lazy in chapter 9 and didn't do good homework problems at all, like no homework problems, some of them. So I made my own, and there's a handout. So there's a handout for the homework problems that they're authored by me. So other than that, it's all out of the book, but the homework problems from the last from the last week or two will be things that I made. Any questions at all on the syllabus? Okay, something I just found out about yesterday, it like ruined my day, is that Google, remember, I don't know, those of you who were in my class in the spring quarter, remember I used the Google Doc thing? Doesn't work for this class. So we're not gonna be using Google because it doesn't work. There's no matrices in Google. Isn't that terrible? It's like, if any of you plan on working for Google, could you please change it? And get some matrices in Google Docs so we can make that work. So instead, I'm going to be using Word to do lectures. And Microsoft Word has matrices. So just let you know, when I share my desktop next, I'm going to have to unshare and reshare because Word's not online. It's on a separate program. So just let you know how things are going to work. Are there any questions about the course before I get on to math?
So for those sections that are going to take multiple days to cover, they'll be due after we've talked about it, right?
So the way it works, so let me just show you, for example, this one. So you'll notice that 1.2, you have problems 10 through 45 due. And then 1.2 will be due on Monday. And then 1.2 on Friday. And then 1.2 on Monday will be 46 through 62, right? And not all of them between, but so the idea is these guys are a very different topic than these guys. So today I'm just going to go over the topic of these guys. And then Friday, it's so hard to start on a Wednesday. I'm so off kilter in terms of the day of the week. So sorry if I keep messing the days. But on Friday, I'll be doing this part of 1.2, which has some chemistry, believe it or not, and a little bit of other stuff too. And then I'll also do the very beginning of 2.1. Do you see that? And then 2.1 goes on and on and on. Yeah, and again, the book's not perfect, but it covers everything. It just doesn't chop it well. And I think you'll agree when you see it. Okay, any other questions before I unshare and reshare? Or new share. Okay, let's go to new share. And let me talk about the agenda. Okay, so now we've left the internet, or at least the screen you're looking at. And let me talk about what we're doing today. The plan is I've kind of done the introductions, gone over the syllabus, and now it's time to do math. So I'm going to start out, and please don't log out because you're saying, God, this is way too easy. There's a reason why we're going to do something way too easy, and you're going to agree in a moment. But I'm going to start out with just systems of equations. You just have a couple equations and you got to solve and talk about how to do that. But talk about it in a different way of thinking about it. Because then what we're going to do, we're going to spend the rest of the entire course after these 10 minutes of systems of equations doing matrices. And understanding that matrices are a much better way of handling systems of equations. So then we're going to look at the matrix way of looking at systems of equations, and I'm going to formalize it. So the first thing you're going to say, well, when you solve a system of equations, there's different things you're allowed to do, and we're going to formalize what you're allowed to do. And then, if you think about it with matrices, those things that you're allowed to do are things that you're allowed to do with matrices without even thinking about the equations. That's the cool thing. And there's 3 of them, and they're called the elementary row operations for matrices. And then there's going to be 2 goals. The first goal is to move it into what's called row echelon form, REF. And we'll talk about what that means, is to make it prettier. And then the second goal and the final goal will be turning it into reduced row echelon form. So it turns out if you want to solve a system of equations, then you want to turn it into what's called reduced row echelon form, or RREF. Okay, I'm not going to be typing out reduced row echelon form probably ever again. I'm always going to write RREF. Now it turns out if all you care about is there a solution, then REF is going to be good enough, and it's a lot less work. But if you want the solution, you got to RREF it. Okay, then we'll talk about the pivot position and pivot column. Again, definitions. We'll talk about free variables, some more definitions. And then we'll talk about if you have 2 matrices, then we can say, are these matrices equivalent or not? And again, we'll have an equivalency relationship definition. So none of this is supposed to mean anything to you, but none of it's too hard either. And then we'll talk about the uniqueness of an RREF matrix. So the idea is that if you RREF a matrix, and then your friend RREFs the same matrix, and you look at each other's answer, and you did it right, you will get the same answer. You're not going to have 2 different answers. Whereas it turns out REF is not unique, but RREF is unique. So we'll see how that works. Any questions about the agenda? All right, if there's no questions, what I'm going to do is I am going to look at, let me double check, you can see it. Yeah, you should be able to see it. I'm going to look at this example right here. Okay, by the way, if you don't know how to solve this, 2x minus 3y equals 1, 4x plus 4y equals 12, you don't belong in this class. Do you agree? Okay, hope you all agree. So but what I want to do is something different. I don't want to just solve it. I want to think about what are the steps in solving it. What are the things you can do to this system of 2 equations, 2 unknowns to solve? Okay. And we're not going to use, and if you remember with 2 equations, 2 unknowns, there are a couple methods. One was graphing, but we want to be able to make sure that we can extend this to 100 equations and 100 unknowns. By the way, do you think that ever happens? 100 variables, 100 dimensional space? Where do you think it happens?
Probably, yeah.
Diffie q's was my guess.
Diffie q's? Not Diffie q's.
Complex problems involving circuits. I remember we had to deal with systems of equations with like circuits.
Yeah, probably not 100. Probably not 100. Keep guessing. Keep guessing. You're guessing some good ideas. Circuits probably going to be more like 7 or 8 variables.
Computer programming.
Yeah, what kind of computer programming?
I'm not sure.
And chemistry, you're going to have equations, but usually that's going to be 7 or 8 also. Artificial intelligence. How many variables do you think there are in the video of a self-driving car?
Oh gosh, a lot.
Exactly. Probably multiple hundreds, honestly.
Yeah, often millions. Okay. Now, of course, you're never going to do it by hand, but you're going to have to write a program to do it. And by the way, if you know how to program in artificial intelligence, you know what kind of money you can make? If you're looking for a job that makes money. Okay. I have a nephew that's doing that, and he's in his 20s, late 20s. He's already worth, I think, $8 or $9 million. Just let you know that. If you want to make money and that's your deal, you get good at AI. And you're going to be doing systems of literally sometimes 1 million equations and 1 million unknowns. Now, of course, I'm going to do 2 equations, 2 unknowns, because I'm going to show you how to do it and to understand the techniques. But the idea is, once you know how to do it 2 by 2, and if you know how to program a computer, you can have a computer do it with the 1,000,000 by 1,000,000. Does that make sense? Okay, there's a lot involved in 1,000,000 by millions because time is an issue. All of a sudden, even with computers, they have trouble when there's that many. So you have to do all kinds of little things. All right, so what can we do? What can we do? We want to solve this. And we're going to think about, you want to be able to extend it to 1,000,000 by 1,000,000 or even 10 by 10. So substitution doesn't work when you're doing 10 by 10. Certainly don't want to go that way. So we're talking about elimination, which is the other way, or addition methods, sometimes I call it. You know, you learn in 9th grade or 8th grade, whenever you learned it. And what can we do to this? What's a step that you could do to this system of 2 equations, 2 unknowns, 2x minus 3y equals 1, 4x plus 4y equals 12? What would be a step?
Multiply the top equation by -2.
Yeah.
Okay. Interesting. I'm seeing a couple answers. Multiply the top equation by -2, and I'm going to call dividing the second by 2, except I think I'd rather divide it by 4, wouldn't you? Not sure where the 2 came from. Maybe it was a typo. You could divide the second equation by 4, right? Do you see that just wants to be divided? Which is the same as multiplying the second equation by 1/4. Any questions on that? Do you all agree you can do that? Okay, so I'm going to do that. And again, this is basic math. You should all understand it, but I want to focus on what we're doing. We're multiplying an equation by a number, okay? Typically, it's easier to say multiply than divide, so we just call it multiply. All right, so we do that. And we get x plus y equals 3. Which is the simpler of the 2 equations, the first or the second, as we're reading it now?
The second.
The second. So I want the simpler one to be the first equation. Am I allowed to do that?
Yeah, it doesn't matter what order they're in.
Exactly. So I'm going to type it out. Switch the order, or switch the first and second equation. Okay. By the way, when we look at, say, multiplying the second equation by a fourth, could you do that if it was like 100 by 100 instead? Could you multiply one of them by a number? Would that be allowed?
Yeah.
Yeah.
Yeah, of course. Could you switch two of the equations? Are you allowed to do that too?
Yeah.
Yes.
Yeah. So I want to make sure that we can do this with any kind of system of linear equations. And by the way, linear algebra. So often I'll just say system of equations. I really mean system of linear equations. But since it's linear algebra, that's just going to be assumed. We're dealing with linear equations. Okay, so I can switch those, which is not hard at all. So let's do it. Okay, and I apologize if this is like boring, because you all know how to do it, but I want to focus on what we're doing instead of how to do it. So I switch them. And the good thing about switching is copy and paste works. The bad thing is with Word, it's a bit of a pain. There we go. Okay, next, what can I do? I can multiply by -1. Okay, I think this is one I may have to mention it because you may not be thinking of this specific way of doing it. But I'm going to replace the second equation with the second equation plus twice or 2 times plus -2 times the first equation. Do you agree that we're allowed to do that? That's kind of the fanciest of all of them. Okay, so what I'm doing is I'm multiplying the first equation by -2, adding it to the second equation, and then whatever we get, that's our new second equation. And that was part of elimination. Do you remember doing that? You might have done that in 2 steps, but we're going to do that and we're going to call that 1 step. Any questions so far? All right, when I do that, then this 2x goes away because a -2x plus 2x is 0. Then -2y, and then plus -3y is -5y. And then -2 times 3 is -6, plus 1 is -5. Any questions so far? Okay, what can I do next?
Solve for y.
Yeah, but remember, I want to kind of use these 3 things I said. I'm going to multiply the second equation by what?
1/5.
-1/5. Right? Right? Because I want y by itself, so I want the negative gone too. And when I do that, the nice thing is I get y equals 1. I'm very close. All right. What's the final thing I can do now?
Plug into the simpler equation and solve for x.
I can plug in, but we don't want to think about plugging in. We want to use an equation to do something to another equation. So what I'm going to do is I'm going to do this replace kind of thing. I'm going to replace the first equation with the first equation plus -1 times the second equation. Any questions on kind of the writing it out? If you're not used to thinking about it in these long written out ways, but we want to think about it that way. And you'll understand why in a little bit. I just wanted to do something that was really easy for y'all to understand first. And when I do that, now we have an x plus 0, because the y goes away. Y plus -1 times y is 0. And then we have a 3 plus -1 is 2. And now we have our solution. So I know this is a little bit awkward, kind of a little different way of thinking about it than you probably used to thinking about it. But there's a lot of reasons why you want to do it this way. One is that if we go back and we realize we have multiply by a number, we have switch two equations and replace an equation with it plus a multiple of another equation, and that's the only things we're allowed to do, then we have a simple set of instructions of things you're allowed to do. And when you have a simple set of instructions, I want to put it into the real world now, that means you can write a computer program to make it happen. So that if you have a 100 by 100 equation, you can actually instruct a computer how to do this. Any questions on that idea? Okay, now what we want to do is we want to say, well, I never used the letters X and Y, did I?
No.
They're never in any of these explanations, right? They're just not there. And I never used the word equal, did I? So what I can do is I can take the X, the Y, and the equal out of this whole thing completely. And if I do that, and I could even take the pluses out, and I can make a minus, a plus, a negative. So I can even get rid of the pluses. And if I do that, I get a matrix. So here is the original problem in matrix form. Okay, so if you remember, maybe I'll copy and paste it so you can see it right above it. So if you remember, we have the 2x minus 3y equals 1. I can get rid of the x's and the y's. I get rid of the equal signs. I get rid of the pluses. And I just get 2, -3, 1, 4, 4, 12. And that's a matrix. Any questions on that? Okay. Now, for computers, why are matrices good? Who knows programming a little bit at least? Any of you know any programming? If you don't, you need to, like for your life, for your career. Any of you want to jump in the chat? Say, I know a little bit of programming. Maybe you know Python or, okay. Some of you know a little bit, okay. If you haven't ever had programming, you need to, okay. You want to get a good job when you're out of here, and when you're finished, you want to know how to program. Yeah. So those who know how to program, what is a matrix? What's the programming words for matrix? Anyone know?
An array.
Yep, it's an array, and in fact, it's called a two-dimensional array. So it's an array of arrays. So it's really easy. It's really easy to code matrices in a computer because matrices are just arrays. And computers, every language, at least every language I've learned a dozen languages probably, and they all handle arrays. And if you can program a computer to do it and then give the instructions, then it'll do it. And you don't have to do all the messy work. It'll handle it. And computers never complain about fractions. They don't mind ugly decimals. They'll just do it. That's a good thing. Any questions on that? So now we want to think about, again, instead of adding equations, now just change the word equation to what? If you're talking about matrices now. So what's the word equation in matrices? 3 letters. Anyone know?
Would that
Nice.
just be REF?
Not quite. That's 3 letters too, but REF is to make the matrix prettier. Should I tell you? If I say it, you're going to say, of course. I promise. Part? Not quite. That's 4 letters, by the way. Should I tell you? Row. An equation is a row. So the first row of this matrix is 2, -3, 1. That's this first equation, 2, -3, and 1. The second row of the matrix is 4, 4, 12. That's the second row, as the second equation of this system. Do you see that? So instead of talking about what things we can do to the equation, what we're going to do is we're going to say, what are the row operations that we're allowed to do? And let me use a word before it, elementary. These are going to be called the elementary row operations. And that's the things you can do to a matrix so that when you do it, you don't change the answer to the system of equations question. So there's 3 of them. And the first thing you can do, and the order doesn't matter, there's 3 things you can do. One is you can multiply. So I'm just going to see what we did. We multiplied by 1/4, remember? Multiply a row by, can you multiply by any number? What do you think?
I'm assuming all real numbers are fine.
Yeah.
Not quite. There's one number you're not allowed to multiply by.
0.
0.
By any non-zero number. I will mention something, by the way, since you mentioned it. It turns out you can multiply by any complex non-zero number too. But this class, we're not really going to deal with complex numbers, except in 1 or 2 places, but we're basically not touching complex numbers. So when I say numbers, I just mean real numbers.
I kind of miss those. When are they coming back?
Complex numbers?
Yeah.
What's your major?
Aerospace engineering.
Aerospace engineering. You may not use complex analysis actually in that. I'm not an expert in aerospace engineering, but I don't know if you do much complex analysis. You do a whole lot of it in physics. You do a whole lot in especially quantum physics and astrophysics. You do a whole lot of it in electrical engineering. Those are the 2 major engineering things that you do a whole lot of complex analysis. So I don't know if you do much in aerospace, but maybe I'm wrong because I'm not an aerospace engineer. I'm quick to tell you that I don't know a lot of things.
Better get a postgrad in something that has them then. Kind of want to work with them a little bit more.
Okay, so one is you can multiply a row by a non-zero number. What was the second thing we did? Remember?
Swapped rows. Like
Yep,
changed.
you can swap any 2 rows. That's always allowed. And the third one, it's a little harder to type, but it's the third thing we did, and that is you can replace a row by the sum of that row and a multiple of any other row.
What about multiples by 1?
That
Like just not changing a row. Could you add? Could you replace a row by the sum of that row with just another row, or does that have to be a multiple
Yeah.
by sum?
Yeah.
Okay.
Well, one is a multiple. In fact, you could even replace a row with that row plus 0 times another row. Of course, you haven't done anything if you do that. Yeah. No, you're allowed to add 2 rows. You know, a row plus another row. Any number, even 0, and for number 3. For number 2, you're not allowed to multiply by 0. Because if we multiplied, you know, an equation by 0, it's just gone, and you can't just get rid of it, right? But yeah, we could add 2 equations, right? We're allowed to do that. That's all that is. Okay, and that's it. Those are the 3 elementary row operations. Any questions on this big definition? All right. So let me do it, even though we really did it with equations. Now let's do it with matrices. The nice thing is I can copy and paste. Except that it numbered it. I don't want to number it. Okay. So what I can do is I can take that matrix and I can multiply the second row by 1/4. And I get 1, 1, 3. Any questions on that? Okay, what was the next thing we can do?
Swap rows.
Swap any 2 rows.
I can switch the 2 rows. It turns out you really want to have a 1 in that top corner. So I can switch the 2 rows, and I get 1, 1, 3 for the first row. And for the second, I get 2, negative 3, 1. Okay. Now what can I do?
Replace a row by the sum of that row and a multiple of another.
Yep. And in particular, I'm going to replace row 2 by row 2 plus negative 2 times row 1. And when I do that, negative 2 times 1 plus 2 is 0. Negative 2 times 1 plus negative 3 is negative 5. Negative 2 times 3 plus 1 is negative 5.
Will you say that in words one more time, what you just did?
Okay, so I replaced row 2 by the sum of row 2 and negative 2 times row 1. Do you want me to type that out?
Yeah, if you don't mind.
It's negative 2. Does that make sense? Okay, now what could I do? What should I do to the matrix now? Yep, multiply. No, I don't. I want to keep, see this 1 up here, top left corner. I want that to be a 1 because that keeps x as an x. Something about row 2, that's a hint. Yeah, multiply row 2 by negative 1/5 because I want it to be a 1. So when I do that, the negative 5s become 1s. And then lastly, I want to make this one a 0. And when I do that, I'm going to replace row 1 with row 1 plus -1 times row 2. And that makes that one a 0. And it makes this 3 a 2. Any questions on that?
That was replacing row 1 with the negative of row 2.
With the sum of row 1 and the negative of row 2.
Okay.
Or -1 times row 2. So very similar to the other third row operation that I did. And I'm done. Why am I done?
Because we have, well, I'm trying to think about it and not using X's and Y's.
You can think of it as X and Y's. Now it's time to think about with X and Y's.
Okay, so we have a 0 in the Y column of the first row, which means X is equal to 2.
Right, and you need a 1 here, by the way. Had this been a 2 as this first number instead of a 1, that's not okay, because then you have 2x equals something. And
then the same goes for the second one. The coefficient in front of X is 0. There's a 1 in front of the Y, therefore Y equals 1.
Exactly. Okay, so I want to mention something because I see that we have RREF, but not quite. This guy, oops. Let me rewrite it. This one is in not REF. I mean, it is REF, but more importantly, it's RREF. This is in reduced row echelon form. Whereas this one here that's REF, which is row echelon form. So notice the difference. The difference is this one here. So what you want to do is if what you care about is the solution, then you want it in RREF form. And what that means is that if you look at the first column that isn't the 0 column, we didn't have a 0 column here, but if we had one that can't do anything about it. But if you don't have a 0 column, the first column is going to have a 1 as its first number. Okay, its first non-zero number, the row, and 0's below it. And then the second will be the same. It'll have a 1 and 0's below it. There's nothing below it, but we're done. So our REF doesn't worry about above it. It only worries about below. Our REF, you worry about above. So this one here in the REF form has a 1 on top, which is okay for REF. But for our REF, above it needs to have a 0. So let me write this out in some words. So REF, that's the reduced echelon form. That means first thing, any rows of all 0 must be at the bottom. Okay. If it's not at the bottom, what can you always do easily?
You can swap rows.
Switch the rows.
Yeah, you just switch, just move them to the bottom. It's really easy, but you just have to pay attention. So if you're coding a computer, you make sure it does it. Okay, that if you get a row, so you have to scan at every step. Do you have a row of 0s? If you do, is it the bottom? If not, move it to the bottom by switching. Does that make sense? Okay, so that has to happen. All right, so now that's one. What you also need is not only need any rows with 0s at the bottom, which we didn't, this example didn't have that, but you want to make sure that the first entry is a 1. And when I say first means that top row, and then move along the columns. And I should say move along the columns. Any questions on that? Okay, and I don't even need top row. I can say all rows. All non-zero rows. So notice in our REF, the first row's first number is a 1, and the second row's first non-zero number is a 1. Do you see that? What we also need is below every one of these ones, I'm going to write special ones, called pivots, are all zeros. Any questions on that? So notice that we have a pivot right here, and below it is a 0. We have a pivot here, and below it is nothing, so we're okay. And that's REF. Then there's RREF. And RREF means do REF, and then get all the entries above the pivots to be 0. So now for the RREF, I have this 1 here, and above it is a 0. Any questions on that? Okay, can this always be done, given enough time?
I would assume yes.
Yeah, the answer is yes. Okay, you can always get a matrix into REF form and into RREF form. I think I'm not going to prove it. It's kind of a messy proof, but it's provable. So it can always be done, and you just kind of go through the steps, and you kind of prove it. The way you prove it, believe it or not, is by writing computer programming code. You just say what the steps are, and you say, therefore, you're done. You know, it is exactly the same way you program a computer, except you'd use programming language, but it's really the same. Is you just go through the steps and say, now you're done. Is you do a recursive algorithm. Do you remember what that means? The programmers better know, but even the non-programmers should know.
It means you take the output from the last iteration, like, I don't really know how to describe it, but you take the last output and use it for your input for the next step, basically.
Yeah, exactly. Exactly. So what you do is you do something in the matrix, and then you look at the matrix, and then do it again, and then do it again, and do it again. And you may have some if statements. If you have this, then do this. If you have this, then you have to do this. You have this, then you do this, and then start over again. Does that make sense? And that's the proof kind of goes that way, and it's a nice little computer programming. Here's something I'm going to give you a big fat warning on. I want you to be able to do this by hand. Now, again, the tests are not going to use Proctorio, but I will let you know something, and I'm a computer programmer, so I do know this. Brains are different than computers. And I'm going to purposely give you some problems where I tell you to do it by hand. And I'm going to know whether you used a computer or not, even though you're showing your steps. And the reason is computers think differently than people. I'm not going to get into that because that wouldn't be linear algebra. That would be AI. And this isn't an AI class. But I will tell you that I can tell whether you did it by hand or whether you cheated and used a computer. Okay, so here's the rule of the course. Okay, not just today, but the entire class. And the rule is, unless I say otherwise, you must do one problem by hand. And then if you feel comfortable that you can do it by hand, then do all the rest of them by computer. Does that sound fair? And I will write on
I
the
go
exam.
for the homeworks as well.
For the homeworks as well. Okay. So in other words, on the test, I'm going to have the same thing. Is I'm going to have one problem due by hand, and I'm going to purposely, I'm going to write it so that if you use a computer, it's going to be obvious to me and not to you, and that'll be cheating. Okay. I want you to do it by hand because computers think differently, and I'm a programmer. I know how they think, and I'm also a person, so I know how I think and how people think. So there are problems where a computer will always do it one way, and a person would never do it that way. Does that make sense? And I'm not going to tell you because I don't want you to cheat, which you know what it means. But trust me, that's how it works. Okay, so I want you to know how to do a problem by. So I want you to know how to RREF. Got it by hand? That does not mean you have to do every RREF problem by hand for the whole course. I just want you to know how to do it. Does that sound fair? Okay, and then it's really easy. You can go to Symbolab or whatever, and it'll RREF for you. But it's going to do a whole different step-by-step set than you would do by hand. Any questions? Yeah.
Yeah, what's the definition of pivots?
Okay, so a pivot, see this one here that has zeros below it? It's the first one on a row that's been REF'd or RREF'd. Do you see that? So in this case, and we're going to do some other examples so you'll understand better. In this case, the pivot is the first one on the row. So there's two pivots. There's this one and there's this one. Whereas this other one is not a pivot because it's the second one on a row. Does that make sense? Any questions on that idea? Okay, and here's something you're going to love this. It's really important that you know how to count how many pivots there are. And what's so wonderful about it is 1, 2, aha, it was 2. Is that hard once it's RREF'd? So counting is really easy if you understand what a pivot is, and it's not some fancy thing. It's just the first one on a row is a pivot. Any questions on that? And in fact, let me define it right here. So a pivot is the first one on an REF or RREF matrix. Okay, any questions on that? And let me give you the next important definition. Let me highlight or boldface this guy. A pivot column is the column that has the pivot. Does that make sense? So in this case, column 1 and column 2 are the pivot columns. Column 3 is not a pivot column. Is that totally clear? Okay, so let's look at another example. Okay, x plus y equals 4, x minus y equals 1, and 2x minus 3y equals 5. Okay, that's a system of equations. Any questions on that? And I wrote down the matrix next to it. Are you Do you think it's not too hard for you to be able to do this, write down a matrix? I'm hoping that's not some mystery on how I got that matrix. Are you okay with that? Because you have to know how to do this, get the matrix out of a system of equations. Just means drop the letters, drop the equals, drop the pluses. Everyone okay with that? Okay, so what we want to do is we want to RREF this. Got it? So let's do that. All right, what can I do? What row operation can I do to RREF this guy? Okay, add 1 and 2. Actually, I think I'm going to add -1 times 1 with 2. Does that make sense? If I add 1 and 2, I'm going to get a 2 instead of a 0. I want a 0 below that 1. Okay, and because it's a hell of a lot easier, I'm allowed to do 2 of them at once. So I'm going to use this 1 to get to 0 out everything below it. So I am going to add -1 times the first row to the second row, and I get a 0. I get a -2, and I get a -7. Oops, sorry, a -3. And then I'm going to add -2 times the first row to the third row. And I get a 0. I'm allowed to do 2 at once if I want to. Always okay to do that. And it just makes it a hell of a lot easier. So if I add -2 times the first to the second, I get -5 here. And -2 times 4 plus 5 is -3, right? If I make a mistake, let me know, but I think so. Yeah. Any questions on that? Okay, now what can I do?
So you added -1 times the first row to the second row.
Mm-hmm.
And then what'd you do after that?
I added -2 times the first row to the third row. And what that does is it zeroes out everything below the 1 because I want to zero out everything below the pivot, remember? To make it a pivot. Is that clear?
Yeah.
Okay, now it gets interesting. Can we multiply the second by -1 and add it to row 3? At this point, we can, but it's not going to help. That'll get rid of this. That'll make this guy a 0, but that's not what I want to be a 0. I want this one to be a 0 because I want to REF. So I actually need this guy to be a 1. So I'm going to multiply the second row by -0.5. Does that make sense? And when I do that, I get a 1, which is what I want. I want it to be a pivot. Pivots have 1s. And I get 3/2 for this guy. And by the way, fractions do happen. Computers don't complain, people do about fractions. Okay, now I could take the first row, as the second row, multiply by 5 and add it to the third row. So when I do that, I get a 0 there. If I multiply 3/2 times 5, I get 15/2. 15/2 minus 3, that's 15/2 minus 6/2, which is 9/2. Any questions on that? Okay, I can now answer a few things. One is how many pivots are there?
2.
Yep, there's 2 pivots, and the pivot columns are the first and second columns. But I can do another thing, and this is really important. Don't lose track of what we're doing and why we're doing it. We're trying to solve the system of equations. What does the third row say?
That 0 equals
It's equal to, yeah.
0 equals what?
9/2.
Okay, and what is the solution to 0 equals 9/2?
None.
None.
There is no solution.
Okay, so what we say is this is what we say inconsistent. So this is inconsistent. Means there is no solution. Is it an E? Yeah, it's an E, sorry. So that means there's no solution. So this is an example where you actually don't need to RREF this if your goal is to solve the system of equations. We just needed to REF, which we've done. Okay, and in fact, not quite, because it's 9/2 should be a 1, but I can do that in a second. Just multiply by negative 2 ninths. Sorry, multiply by 2 ninths. And I get 0 equals 1. And it's inconsistent. I don't need to REF it, RREF it. I only need to REF. So if what you care is it consistent or is it inconsistent, all I care about is REF. If I want the solution, if there is one, then I need to RREF. Any questions on that? Okay, so that's a nice little example where you have a system of equations and there's no solution and we get inconsistency. Any questions on the example before I go to the next one? Okay, so let's look at the next example. All right, so now we have x minus y plus z equals 0, x plus y minus z equals 2. And I can turn it into a matrix. Is that clear? And now what do we do? If we want to REF or RREF, what can we do?
Add -1 times the first row to the second row.
Yeah, I add -1. I replace the second row with -1 times the first and the second, or plus the second. So let's do that. And I get a 0 right there. And I get a 2 right there. I get a -2. And I get a 2. Any questions so far? Okay, now what can I do? Nice, easy one. If I want to REF, not add.
Multiply the bottom row by 1/2.
Yeah, I'm gonna multiply the bottom row by 1/2 because I want the pivot to be a 1. Remember that. To REF, I want to first REF and then maybe RREF, but at least REF, which means I need that 2 to be a 1, which isn't hard to do, but you have to know what to do. So that just becomes, I multiply by 1/2, I get a 1, I get a -1, and then I get a 1. Any questions on that? Okay, I don't have inconsistent because, again, this reads x minus y plus z equals 0 and y minus z equals 1. That's not inconsistent, which means I got to keep going. So what can I do now?
Can't we just, no, that won't work. Never mind.
Okay, so I have it in REF. I want RREF, which means I want that -1 to be a 0. It's not hard, but you have to know what to do. It's not tricky or anything. How do I make that a 0?
Would you just add row 2 by it and store it in row 1?
Yeah, replace row 1 with row 1 plus row 2. And what I get when I do that, that -1 becomes a 0. This one becomes a 0 also, right? And this one becomes a 1. Any questions on that? All right, so now I have it in RREF form. Now let me explain why this is important, okay, why this helps. Remember, our goal is to solve this system of equations. Okay, so now I know it's not a requirement, but let me ask you, this is going to be a little survey I'm giving you as a group, is type in yes in the chat box if you've had vector calculus, type in no if you haven't. So if you took 202, you've had it. It's not a requirement of this course, but usually everyone's a yes anyway. Okay, so you're all saying yes, so I can assume it. Okay, by the way, what's your guess? Do you think I had this? Or do you think I had vector calculus first?
I don't know.
I actually had this. Now here's something. I've never met anybody who had it in this order, and it's just because it was weird. I had it in high school. I had it before I took calculus. And that's a long story, but the point is you don't need calculus. Do you need calculus to do anything we've done?
No.
No, nothing. But I did this actually before I did calculus. It wasn't my choice, by the way. It wasn't because I'm weird. It was because I was unique, but not, it was my school. Okay, so what I do now is I realize that the first 2 columns are the pivots. So let's write this down. And the third column. So when you have a column that's not a pivot, then we call that a free variable. Let me highlight that because it's a definition. So the third column, in this case, Z, the Z column, is a free variable. Now here's what that means. Since you've all had vector calculus, that means that our Z can be thought of as a parameter in parametric equations. And I can now rewrite this as X is equal to, now I just read this off. Well, it's equal to negative T. It's equal to 1. X is equal to 1. That's how I read this. Remember, there's an equal before the last column. And Y is equal to, well, let's read this out. It's going to be equal to T plus 1. Or let me write it as 1 plus T, same thing. And Z is equal to T. And that's how I get this parametrically. Because T is our free variable, so it gets the parameter T. So now I treat the Z as a T. Anyone lost on what I just did?
So if we had a third equation to this, that would not be the case, correct?
Well, if you had a third, let's just put it this way. If Z was a pivot column, if all 3 were pivot columns, it would not be the case.
Okay.
Okay. Sometimes you could have 3 equations, but one of them is redundant. That can happen too, as we'll see. Any questions on this? So now we have parametric equations, which is important. Okay. You could also write it in vector form. You could say XYZ is, I'll just say it, XYZ is 1, 1, 0 plus 0, 1, 1 t. That's how you write in vector form. So the idea is with matrices, you can do vector calculus. Okay, you probably hadn't thought about it that way, but you can. All right, so now let's do a next example.
When we're doing RREF ourselves, would you like us to write out what we do each time?
Yeah, so if it's the one question, okay, again, you get to choose which one. If it's one question where you're showing that you know to do it by hand, write that one out. Show as much work as you can. And all the rest of them, that's okay, you can use a computer. Does that sound fair? I'm trying to be reasonable. And on a test, it'll be very clear. It'll say, do this one by hand. And all the rest of them, you're free to use a computer. All right, let's do this one. X plus z equals 1, y minus z equals 2, and x plus y equals 3. Got it? So I turn this into a matrix. Okay, yeah, I'll write this down. Okay, turning into matrix is okay if I don't write down, I turn this into a matrix. It's easier. So I turn this into a matrix. And you don't have to say I turned it into a matrix. Hopefully that's obvious. Now what I'm going to do is I want this 1 to be a 0. So let's write it out. So I'm going to write it out. I'm going to write it out in abbreviations if that's okay. I'm going to have R2 goes to R negative 1 times R1. Oh, sorry, not R2, R3. Negative 1 times R1 plus R3. And when I do that, this 1 becomes a 0. This 1 stays a 1. This 0 becomes a negative 1. And this 3 becomes a 2. Any questions? So that's how I write it out. I write it out with a kind of symbol arrow forms. Hopefully that's good enough for you. Okay, well now I got to deal with the third row because under that 1 is a 1. Do you see that? And I want to REF. So now what I'm going to do is I'm going to replace row 3 with negative 1 times row 2 plus row 3. Now, what special thing happens now with this example? What do you notice? Yeah, we got a bottom row of zeros. That's important, by the way. Okay, now if I want to RREF, because we don't have a no solution, 0 equals 0 is fine. I'm going to take row 1 and I'm going to replace it with row 1 plus row 2. And what I get, wait, I'm sorry. That was a mistake. I apologize. I don't need to do anything. It's RREF'd. because there's nothing above this 1. So I apologize if I thought about too much. All right, what do you notice now? This third row tells you nothing. A row of zeros gives you no information. So even though we started with 3 equations, we end up with only 2 equations. So we can say column 1 and column 2 are our pivots. Column 3 is our free variable. Column 4 is the equal variable. So let's write this down. Column 1 and 2 are pivots. And column 3 is free. And because of that, we can say that Z is going to be T, because Z is the third column's variable. And we can say that X is equal to 1 minus T. We can say that Y is equal to 2 plus T. And we can say Z is equal to T. Any questions on that? Any questions at all? No big deal? I want to state a theorem, which I think I'm not going to prove, but I'm going to state it because it's a nice theorem. And that is that RREF, so let's write down theorem. RREF is unique. Okay, so what that says is that if I RREF a matrix and a computer RREFs the same matrix and we don't make mistakes, then we'll get the same answer. There is only one RREF answer, because there's lots of choices on how to go about RREFing, but the answer is always the same. Any questions on that? Okay, and I could prove it, but it would take a long time, and I don't think you'd get much out of it. We will prove a lot of things in this class. Today's not a big proof day. Today is getting used to matrices. Any questions at all on this theorem?
So if we have 3 unknowns in a matrix and we don't have any information on the third variable, we assume it's a parameterization.
Yeah, so let me give you another example, because I want to answer it, but your statement wasn't quite right, and you'll see why in the next example. So I'm going to make this up. I didn't know how much time I was going to have, so I'm going to make one up. But I need to do that and that. Insert symbol, equation, matrix. I'll just pop in a matrix and do some more things. It's going to be big, so it's going to take a bit of time. Sorry about that. Okay. So let's suppose we have a matrix, and I'm going to do one that's already RREF'd. that what I want? Just a minute. No, that's not what I want. Yeah, that's fine. Takes a moment to type these. But it's better than Google. Google, you can't even do it. You do it with an add-on with LaTeX, and it's really hard and miserable. Okay, first thing. Is this RREF'd? What do you think?
Yes.
Yeah, you can, because if you look at the first row, the first number is a 1. Do you see that? You look at the second row, and by the way, everything below that 1 is a 0. Everything above the 1, there's nothing there. If you look at the second row, the first non-zero number is a 1, and everything above and below is a 0. And then if you look at the third and fourth and fifth row, those are all zeros, and they're in the right place. Is that clear? So now, what are the pivots? What columns are the pivots?
Row 1 and 2.
Yeah, just row 1 and 2.
Okay, it's columns, not rows. Pivots are columns.
1 and 2.
1 and
No.
3?
1 and
3.
3.
Yeah.
1 and 3, because the pivots are these these ones that happen as the first thing in the row that isn't a 0. And notice that's this guy, which is in the first, oops, this one, which is in the first column, and this one here, which is in the third column. Any questions on that? So pivots are column 1 and 3. So the free variables are columns 2 and 4. Any questions on that? So now if we want to write this as a parametric set of equations, then notice that let's just call it, how about x comma y comma z comma w. You need a letter for the 4, so it's called the fourth one w. Sound good? You just want the first 3 to be x, y, z. That's standard. You could do x1, x2, x3, x4, and that's what I would normally do on a board, but typing it is really a pain. So and call it x, y, z, w. So if x, y, z, w are the defined variables, then that means first thing we're going to have 2 parameters, not 1. And I'm going to let you choose, since I'll ask you what Bruce tended to do. What 2 letters did he use if there were 2 parameters in vector calculus?
P and Q.
He used P and Q? Okay, not S and T or U and V?
U and V as well.
Okay. I think I'd rather use U and V because that's more standard. P and Q has some other special meanings. So we can say that X, and I'll even write it this way, of U comma V is equal to, now we can read this out. Well, we get 2U and 2V, but moved over to the other side of the equation. We have a 4, so it's going to be 4 minus 2U minus 3V. We're going to have Y of UV is equal to 1, just 1. We're going to have Z of UV is equal to U, and W of UV is equal to V. And there's our parametric form of this. What do you call it in vector calculus? What kind of shape thing is it? Starts with an S. I know it's been a month. But if you have two parameters, what do you have?
A solenoid?
Simpler word. A word even I don't know, a sixth grader understands. It's not a sphere. It's linear algebra. It's a surface. It's a surface when there's two variables. You got that last quarter, right? One variable, right, is a curve. Two variables is a surface. Now it's a surface in 4 dimensions. So you can't draw a picture of it or anything. But it's a 2-dimensional surface in 4 dimensions. Any questions at all on this example? Any questions? Okay, so this is an example. Again, this could happen where you have more than one free variable, and they're not the last ones. They're in the middle somewhere sometimes, but you know, anything could be a free variable. Any questions on this idea? Anyone lost? Just want to make sure I'm not killing you. All right, let me just go through because we have a minute or two left, but I think I've got everything I've done. Oh yeah, one last thing. And that is equivalent matrices, and that's just a statement. I can do that in the 1 minute. So definition. And that is two matrices. And I'm gonna, we typically use capital letters to designate matrices, by the way. And A and B are the two most common because they're the beginning of the alphabet. A and B are called equivalent if RREF of A is equal to RREF of B. So let's highlight this guy because that's the definition of equivalent. So if you RREF two matrices and get the same thing, then they're equivalent matrices. Do you remember what equivalence means? It's not the same as equal. Just in general math equivalent word. It means it has a
transform one to become the other.
What's that? Transform one to become another. Kind of an idea of it, but it's actually, there's a very specific definition. And that is two things are equivalent. If A is equivalent to B, then B is equivalent to A. If A is equivalent to B and B is equivalent to C, then C is equivalent to A. Do you remember those? And A must always be equivalent to A. And you'll see that this works. Okay, where RREFing is the thing. So if RREF of A equals RREF of B and RREF of B equals RREF of C, then RREF of A equals RREF of C, right? If RREF of A equals RREF of B, then RREF of B equals RREF of A. So you could check the relationships and they work. That's what equivalence means. It means that you have commutativity. So it means A is equivalent to B is B is equivalent to A. That means commute. You have reflexive, it means A is equivalent to A. And you have the transitivity, A to B, B to C, then A to C. Okay, and the way you find out if they're equivalent for matrices, you RREF both of them, and if you get the same thing, then they're equivalent. If you don't, then they're not equivalent. So that's about it. We're out of time. So I'm going to stop the share. And I am going to stop the recording.